Hello everyone. In this video I show you how to build a calorie tracker app using the Flutter open source framework developed by Google. So first I'll give a demo of the various screens in this application that we're about to build. So here it is. I'm running it on an Android emulator. And first let's start out with the day view screen. So you can see here for today we have one entry, which is tuna sandwich, and it shows the carbs, proteins, and fats for the day. So if I open up the add food modal and add something like chickpeas and give it the necessary information, so I provide all the information on calories, carbs, proteins, fats, and grams. And then I click OK, and then we can see chickpeas is now added, and our calories for the day has been incremented upwards. So 20 plus 10 carbs has a carb amount of 30 in total, and then protein's been added, and then so it just basically adds everything here in the this screen right here, and this shows the individual records for tracked food. And we can go back however long we wish, and then up to today. So let's go back to here, add a new food, cheese sandwich, 20, 30. And then let's add this one. So you can see now yesterday has a new entry for this food. And then we can move to a different date. And let's say we want to delete a date that has a lot of entries. So let's say we want to delete this entry. If we click the delete button, we can see that that entry's been deleted. And then, so that's basically how it works. It's pretty simple, not as extensive as MyFitnessPal, but it gets the job done. It's a simple calorie tracking view, which allows you to track the food. And if you notice this status or progress bar, so this is basically the calories for the day. So now we have two entries, we have two food entries, and we can see the carbs are at 30. This tuna sandwich entry has a carb value of 20 grams. So out of 30, that's 67% of the total carbs for the day, and the remaining 33% is owned by the chickpeas, which has a gram amount of 10 grams. So that's how this graph works. So this is basically carbs, so it's color coded. So we can see that carbs is in red, so if this is red, protein is green, fat is blue. So that's how this day view screen works. So next, let's go on to the history screen. So the history screen uses a time series chart built using the charts Flutter library, and uses Google Firestore database to fetch data and display them. So we can see over here that all our data from all our entries, which goes up to March 30th, which is today, is being tracked, and all the records have been added together. So let's say we have 3 entries for March 30th. It'll add all those 3 entries and then display it as a single entity. So let's say we have 3 entries of 200 calories each, so that'll amount to 600 once we add that up in total. And this chart was made possible by this charts Flutter library. And next up is the history screen. So that's basically it for the history screen. Next up is the settings screen, and oops, I have a breakpoint set here. Yeah, so the settings screen is basically just a UI it's kind of I mean it's just a UI, so it doesn't actually change the state or settings of the application. But this will do for now, and basically just shows you this UI. And this was built with this library, Flutter settings UI library. And yeah, so that's the application. So now that you have a better idea of what we'll build in this video, let's get into the development process. So before starting anything, we need to go to this link right here. I'll include a link of this GitHub repo in the video description so you can look at it. Go over to the starter template and download this project into your local system, because this is a template for this project and it'll make development much easier. Or alternatively, you can start a new Flutter project and follow along that way as well, but that would be a lot harder, and it's preferable if you do it this way. And then once you have downloaded this starter template branch into your local system, make sure to install Flutter. So go to this URL. I'll try to include the links in the video descriptions, but just search Flutter install and you can download the Flutter SDK. And then once you have that, we'll also need Android or Visual Studio Code or Android Studio if that's what you prefer. I prefer Visual Studio Code, so make sure that's installed. And now once that's done, we'll need a Google Firebase project for this application. You can see that I've already created one called Calorie Tracker. Once you've created a Google Firebase project, it'll give you the option, or it'll let you download this Google services.json file. So what we have to do is we have to download that file, and then we have to go to Android app and then place that file right here in the Android app folder. So this is done so that Google Firebase is able to connect with our Flutter application, and it is mandatory that you place it in the Android app folder, otherwise it won't be detected. So we're going to be using the Firestore database for this project. So let's create a Firestore database instance. So I already have one created in this project, so I'm going to go to a different project I have and then click create database. Say start in test mode, go to next, select the region that's closest to you and then click enable. That'll create the Calorie Tracker database, and once that's created, just click on start collection and create a collection called food tracks. You don't have to name it this, but it'll be easier if you do, because the application is based on this name. Once that's created, we now have the Firestore database set up, and here you can see all my entries, which are all just food track instances. So once that's set up, we can go over to VS Code, and what we have to do is we have to import the project that we downloaded from GitHub into our workspace. Once that's imported, we'll have to run the following command. So make sure to cd into that folder directory and run pub get, flutter pub get. So what this command does is it fetches all of the necessary packages used for this application and all the dependencies. So it's going to fetch everything. Alternatively, you can go to pubspec.yaml, and there's this button right here, get packages. If you click this, it'll download all the packages as well. So this is the setup of the project. In the next part, we're going to be coding the actual files for all the screens and all the other stuff you see in this application. So I'll see you there. On to the development part. So let's start with the main.dart file. So I have main.dart opened right here, and the format we're going to be following for this tutorial is I'm going to explain what the important parts of the code do, and then you can probably add it if you're starting with the starter template, or if you just want to go through it just like me, just go to the GitHub URL for the source code in the video description, and you can follow along. If you clone the master branch, all the code will be there. All the code for the full application will be there. So I'm just gonna go through this quickly, and yeah, well, let's get into it. So first, we'll start off with the main method. So we have future void main async. So instead of the standard void main method, we have to specify the return type as future void because we're using the async and await keywords in this method. Since these keywords are asynchronous, we have to adjust the return type of this method accordingly. So we're, even though void is not even a return type, we still have to use a future keyword because we're using async await. And then we have our class calorie tracker, and also over here, so what we're doing here is we're instantiating Firebase, which is required in order to establish the database connection to the Firestore, the Cloud Firestore database. And then we're enabling shared preferences service. This is used for caching services. And now we're saying run app, which is our calorie tracker app. So this class is the main entry point for the application. It's responsible for rendering the homepage widget when the app is first launched. Its build method does the rendering and uses the change notifier provider wrapper class to set a dark theme for the entire application. And this is done with the dark theme provider class. And we can see over here that it's rendering home widget, and home widget is assigned home page class, and home page class is defined below. So this class is the home screen for the application. This class renders 3 buttons for navigating to the day view, history, and settings screens of the application. We use navigator context, navigator of push material page route for the routing. So for example, we have these 3 buttons here, and for their click events, if you press on the day view screen, then it's going to go to the day view screen, and then accordingly for the other 2 as well. So that's how routing is being taken care of. So now we can start with the model files. So the model files are over here, and this is going to be our main model for this application, and it's basically a food track task. And this models an instance where the user tracks the food that they are consuming. So it has an ID, it has a food name, calories, carbs, fats, protein, the meal time. So I left it as a string, even though I should make it an enum. But basically it could be either breakfast, lunch, dinner, or a snack. And then you have the created on, so what exact date time did you consume it, and then the grams of the food that was consumed. Then we're creating to map and from snapshot. So from snapshot is useful for converting the database records into food track task class instances. And yeah, so that's basically it. We have the standard to JSON from JSON to converting back and forth from JSON, and also to map to transform a set of maps into string dynamic. Um, Moving on to the food track entry class. So the food track entry class will be used as data points for the Flutter, the charts Flutter time series chart that we'll be developing in the history screen, so that date time graph is modeled or uses data points from this class. So it uses the date as the x-axis and the calories as the y-axis. So next we can move on to the database files in our services folder. This is the class used to interact with the Firestore, the Cloud Firestore instance that we created in the previous steps. And UID is the universal identifier for the Firestore instance. This value can be found by accessing the Firestore database in Firebase console. And then food track collection is the Firebase Firestore instance that allows us to connect to the food track collections in the Firestore database we previously created. And notice that it's querying or looking for food tracks, which is our database collection name right there. Next, we have add food track entry. So this is the method used to create a new record in the food tracks Firestore collection. Notice that the record identifier is in the milliseconds since epoch value based on the food track tasks instances created on field. This is done to ensure uniqueness in the collection. So we can see over here that created on is a date time value. And in order to create a universal identifier for these records, what we're doing is we're converting that created on date time instance to a milliseconds format and then converting it to a string. So this is going to be the ID and this is going to be the value. So if we go to Firebase, we can see that we have a bunch of millisecond values, and this is the key that we're using to hold these food track instances. So we're not using the traditionally used ID method, we're using date time instances, and just makes querying and fetching and identifying data much easier. So that's why that was done this way. Next, we can move on to the delete food track entry method. So this method is used to delete a record in the food tracks Firestore collection. It uses the milliseconds since epoch value based on the created on field from the food track task instance that is passed as a parameter to identify the record to be deleted. So it identifies the record using that millisecond value and then deletes it. Next, and we can get rid of this print function call. Then we can move on to scan list from snapshot. So this method is used to convert the data in query snapshot, the response object from Firestore to a list of food track task instances. We use the popular map function in order to do so. And what we're doing is we're taking the query snapshot, which is a snapshot of the current state of this collection. So a current collection would consist of all these records, and it's going to be in array format. Now what we're going to do is we're going to map over that map, and then we're going to convert every single instance represented by doc into a food track task, and then convert that map object to a list. Then we're going to return that list, which is this, fits this return type. Next, we have get food tracks. So this method is used by a stream provider instance in the day view screen, and we will get to building that soon, so don't be confused. This is basically used to provide a list of food track task instances that'll be displayed in list format. Next, we have get all food track data. Get all food track data. So this method is used to fetch all food track records from the database and then return them in a list dynamic future object. Note that we should avoid using the dynamic data type whenever possible, but it would be acceptable in this context because we're not 100% sure of what is being returned as a response from the database. So we're awaiting the value and then we're assigning it to a dynamic value. For more information on values or the dynamic data type, check out this article by Flutter by example. I'll link to this article in the video description so you can check it out if you want to. Next we have get food track data by string UID. So we're searching for a specific food track instance. This method is used to fetch a specific document from the Firestore database based on that millisecond value, which is assigned as its key. It can also provide the same result as get all food track data if the UID is set to the collection name. So the collection name as of now is Calorie Tracker B7D17. If we pass that in here, it'll get all the records. And then this was something that was newly added. It's mainly used to create some unit tests for the mocking the database functionality, but let's not get into that right now. So next we'll be moving on to the shared preferences file, and the shared preferences package which we import here is used for the common tasks of storing and caching values on disk. This service class will serve to return instances from the shared preferences class and therefore follows the singleton design pattern. As you see here, we're getting instances, and on top of the above functionality, this class also assists in providing the dark theme functionality described in the main.dart file. We could see that we use dark theme provider right here, and to assist with this, it uses get dark theme and set dark theme. And so this is the null operator, so this double question marks operator, and it's basically indicating that, or saying that, if this value is not null, then return this value, but if this value is null, then return this value. So return true if this is not this is null, and if this is not null, then just return this value. And again, it's called the null operator. Next, we can move on to the theme notifier class in the providers folder. Over here, we have a theme notifier with change notifier. So the with keyword is similar to mixins in JavaScript, in that it's a way of reusing classes, methods, and fields in a different class that is not a superclass to the initial class. So when we say with, we're basically borrowing change notifiers, fields, and methods so that it's accessible to dark theme provider, but we are not extending change notifier. So it's not a superclass to the provider class. So this class will serve as a provider to the Calorie Tracker App state class in the main.dart file, while also enabling dark theme that the application will use by default as of now. So providers are important because they help reduce inefficiencies having to do with re-rendering components whenever state changes occur. So when using providers, the only widgets that have to be rebuilt whenever state changes occur are the ones assigned as consumers to their appropriate providers. So instead of having to rebuild an entire component tree, you could selectively rebuild only the ones that are relevant. And here's a great blog post on change notifier provider and consumer, basically the provider and consumer data, design pattern. And basically, if we didn't use providers and consumers and we had a change in role here, every single component here would have to be rebuilt. And as you might guess, it's very inefficient to do that. Instead, if we use change notifiers and providers, where this would be the provider and this is the consumer, whenever the provider changes, only the consumer has to be rebuilt. So that would reduce a lot of inefficiencies. And I'll link to this article in the description if you want to read more into it. So next, let's move on to the utils folder. Next, we're going into the date time series chart.dart. This class is responsible for displaying a time series chart that will be shown in the history screen. And in init state, in this lifecycle method, we call get all food track data method in order to fetch all the food track entry objects from the Firebase data store. And this method fetches all records from the food tracks collection, which we are converting into food track entry instances and then adding them to a list right here. We're adding it to a list right here and then sending it to populate charts with entry. And this method is exactly what it sounds like. It populates the chart with entries that we got from the previous method. And we're basically, so we're doing some additional functionality here. We're aggregating the calorie amounts based on the date. So for example, if there's 3 food track entry instances with a date value of March 25th, 2022, and calorie values of 300, 400, and 500 respectively, then the new list food track entry list would contain only one food track entry instance with that same date, so March 25th, 2022, and that instance would have a calorie value of 1200. So that's basically adding those previous 3 values into one instance. So we don't have a lot of duplicated and confusing data in the chart. So we want to aggregate calorie values by date, and this is the logic that allows us to do that. Once the new list food track entry list has been created, the set state method will be called to assign that value to the result chart variable. Consequently, the widget will be rebuilt and the charts.time series chart instance will display the updated chart data. So this chart.time series chart is present in the build method, and this method will render a scaffold layout containing the title of the time series chart and the actual time series chart itself, and we're passing in the data that we got from over here, and we're setting animate to true to give it some animations. And if the data is not received in the time of rendering, within the time of rendering, then we render a circular progress indicator bar to indicate that it's still loading for the user. Moving on to the constants.dart file. So this is pretty simple. It's just the collection name for the Firestore database that we're using. and this could change depending on whoever uses it. So if you are using this application, make sure to change this value to whatever your file store collection ID is. Next, we go on to theme colors. So these three color codes are what I use to designate the colors for the carbs, protein, and fat in the day view screen. Feel free to change them if you want. And next, we can go on to the UUID field, so Universally Unique Identifier class. And this class basically generates random universally unique identifiers. Most frequently uses IDs when creating new instances of model classes, although I don't think that we're using it for much. So there's a cool feature in VS Code where you can click Find in Folder and say UID to find all instances of where we're referring to this class. And we can see here that we're using UUID to generate a ID for the ID field in food track task. So we are using it once, but again, in order to store it, we're using the date time fields millisecond value. So it's it wouldn't be applicable on the database level, but yeah. So that's our accessory or unessential files. So basically, from now on, we're going to be looking into the page files. So building the page. So let's get into it. Now we'll start out by coding the screens for the application, so the pages for the application. First, let's start out with the day view screen. So the day view screen is basically this screen right here, which is the main focal point of the application. And it basically allows you to add food and delete them. So we can delete food here, and it shows you an overview of what you've eaten in the day. So first, we'll start out with the calorie stats.dart page. Again, if you need this template, just visit my GitHub source code repo linked in the video description. Now let's start out with explaining what we're doing here. So date picked, total calories, total carbs, total protein, and display calories are variables to store nutritional data for the date that is picked. And then we have date check. So this method checks if the date time value is equivalent to today's date. This method is used for prompting the user to add food in the current day view page. So it's basically checking if the date picked value is equivalent to the current day. Next, we have macro data. So macro data is an array that is used to store the macronutritional values and quantities. So carbs, proteins, fats, and grams would all be stored in this macro data array. And this will be stored for every single food instance that's added here. So every single food instance has its own macro data array. And where this comes into play is over here. We can see we're populating these variables into the macro data array. We're inserting it, and then we're using that. So we're assigning this the third index to be grams or carbs, first index to be protein, second index to be fat, and first index to be calories. So that's how that works. And in the render method, we're basically displaying a pie chart. So for fat, carbs, protein, and then total calories will be displayed in this manner. So we have a pie chart, and carbs are in red, protein in green, fat in blue, calories in the middle. So this whole widget right here is being rendered by the calorie stats Dart file, and yeah, so this is how that's done. Now we can add code to the dayview.dart file, and so we have create state over here, and this method creates a mutable state for the dayview screen widget. So the dayview screen widget extends state, and it is a stateful widget. And over here we have a bunch of variables or fields, and the most important one is the value field. So this value field holds the current date that the dayview screen is set to. So the left and right buttons allow the user to switch dates accordingly and will be updated using this value variable. So when I press the left button and keep going left, I'm actually updating this value variable to this current date. So in this case, it's going to be March 19th, 2022. And if I go forward, then it's being updated accordingly as well to March 24th, 2022. Today is self-explanatory, so it's basically today's date. And next we have database service. So this database service instance is used to fetch and add records to the food tracks collection in the Firestore database that we set up in previous steps. And it requires the collection ID, which I've pasted here. We should probably hard code this, and yeah, I'll get around to hard coding it because it's not good to leave it just like this. It's not a good design pattern. Next we have instant init state, and this lifecycle method initializes the add food track variable to an empty food track instance. Then database service get food track data is called to fetch all food track instances from the Firestore database. So, and we're passing in database UID, which is this. So now that we know that that's the value, we can replace it with this. So yeah, that's I guess a little hint or tip that if you can find a way to have a constants file that has the value of repeatable blocks of code, it's preferable to make a constants file and then export it and use it in multiple ways, so that in the future updating that code is going to be easier, because all you have to do is change this value and both these two instances values are going to change on their own. So that's just a little software engineering tip. Next we have reset food track. So this method is used to reset the add food track variable to an empty food track instance after adding a new food track instance in the add food modal. So if we go over to the modal and say cheese and provide some values. Oops. I would provide some values. Now, once that cheese food track instance is added, reset food track has to be called in order to clear this instance's data. All this data has to be cleared so that when I add a new instance, the new instance has that results that are unique to its information that's inputted. So we need to have this method for that reason. And then we have the add food button. The add food button, show food to add, show food to add, show food to add, show amount had, show amount had, and show food form, show food form, show add food form, show add food form, and show user amount. These methods that I've just stated are responsible they're used to render the add food modal, which we can see by clicking the plus icon. That pops up when tapping the plus icon. So that's what these methods do. They basically return widgets that allow us to create this add food modal, add the necessary information, click OK, and then have it rendered or added to the current day's food list. Then we have show date picker, show date picker, and this is responsible for rendering this date toggle feature that we see here. It allows us to switch between dates in a very easy to understand way. Next we have, mainly we have the build method. So we're basically building this day view screen, and so this is basically the render method. We render the add food button and the date picker widget onto the app bar. Then in the body we use the database service class is used to fetch all food track instances, which will be listed using the stream provider class right here. And if you want more information on the stream provider class, here is a great documentation page on PubDev. I'll include a link to this in the video description, so you can check it out if you feel, if you wish. And then the food track list class will render the listing, so food track list. It will require the value argument, which is the date picked by the user, and it will use it to filter out the food track instances that match within a 24-hour period, and render those instances accordingly. So let me try to find where that's occurring. So we have food track list, and over here we see find current scans, and over here is where our date time filtering process is taking place. So we're getting the date time, which is a scan date, and then we're comparing that to the current date, and the current date is the date picked, and the date picked is the value that's passed in here. So the value, for example, it would be March 26th. So the date picked value would be March 26th, and then we're going to iterate through every single Firebase record instance, and we're going to check if that instance was created within the day of March 26th. If it is, great, we'll add it to current scans and return it. Then over on this list, we see this list of instances that are being created. So if multiple instances were added, then we see a lot. And it's because of this filtering functionality that we've implemented. And then we have the food track tile class, which is used to render single items in the list that the food track list class will render. These items will show the calorie amount, macronutritional amounts, and percentages for those values in comparison to the overall day's values in a chart format. Lastly, it will also render a delete button. So this row right here, this tile, is actually an instance of the food track tile class, and we can see it has a delete button, so that we can easily delete any food track instance we wish, and in doing so we set the values of the day to 0. Okay, so next so that's basically it for the day view screen. Again, this is the main focal point of the application. Next we have a secondary screen called the history screen. and let me bring that up here so we can see a chart right here. We should probably make it more visible and make the X and Y labels more visible, but here's where it stands as of now. It's basically aggregating all the instance data into a single day, adding up the calorie values for a single day, and then displaying those calorie values. And to build this screen, we go to the history screen. So the history screen just renders a simple time series chart using the charts Flutter library. It uses the date time chart widget right here, which was covered in an earlier section of this video to accomplish this. So right here, this is the date time chart that we see over here. So next we can move on to the settings screen. Settings screen is accessed by clicking the settings button, and yeah, so there's not much to explain here. So it's basically just a UI. It doesn't do any it doesn't change the settings of the application as of now, but what we're using to create this UI is the settings UI library, which is right here, Flutter settings UI library. To create these nice UI settings pages. And what this library provides us with are the settings section, settings list, and settings tile classes to create a typical settings screen as seen in most modern mobile applications. Okay, so once we've got to this point, we've finished creating our application. So again, if you're having difficulty or need help, just go to my GitHub source code, which is linked in the video description, and I'd recommend typing along, because when you type along, you're more likely to understand what you're typing instead of if you were to just copy and paste. So I recommend typing along, but yeah, within reason, of course. I mean, some of these render methods are very long. For these, you can copy and paste, but some of the logic that we're doing, for example, in the database, it's good if you type this, because it'll help you understand what's going on. But anyways, look to my source code if you ever get stuck, and hopefully you should be able to get the application up and running. Now, before we end, I want to give a brief summary of routing in Flutter and how we've chosen to implement routing in this application. So there's basically two types of routing. There's imperative routing, where the navigator widget, and then there's idiomatic declarative routing via the router widget. Traditionally, most web applications use idiomatic declarative routing, while most mobile applications use some sort of imperative routing mechanism. As a general guideline, it's best to use imperative routing for smaller Flutter applications and idiomatic declarative routing for larger applications. Accordingly, since this is a very small application, we have chosen the imperative routing mechanism for this application, as evident by the navigator of method. So again, we'll use find in folder feature, and if we search for navigator of, we can see that this is numerously used in the app, and this is an instance or case of imperative routing, where we're saying navigate to this screen whenever this button is clicked. So this is the on pressed listener. So that's how routing is being done in this application. All that's left is to basically run this application using the VS Code debugger if you're using VS Code to develop the application. And in order to do so, just go to the Run and Debug tab, click on Add Config, select your project, and then that should create a launch.json file. Just make sure that you have the following settings. So you might have to add no sound, null safety, and -d Chrome if you're running into some build errors. You might not have to add this, but if you do, you know what to do. And then just click the play or start debugging icon, and that should, well, initially it's going to take a while. It takes about 2 minutes to install everything and build the project, but once it's up and running, it should look like this. And yeah, so I'll also link some articles on how to set up the emulator for VS Code if you're confused about that. I'll link this article and this article. So this is if you're using Android Studio for Flutter development, then you'd find this article useful. So I'll link it in the video description. And here's my page, GitHub source code link. And yeah, so if you managed to follow along this far, congrats. You now know how to build a calorie tracker application, or at least the theoretical knowledge, or learn something useful about Flutter. And so feel free to leave any feedback or criticism. Leave them in the comments below. If you found this video helpful, consider liking and subscribing to my channel. Thanks for watching my video, and I'll see you in the next one.